Let me finish this example. All right, so we have this. So we're not, I know you're thinking that, oh, we're done, right? Well, almost. Remember, we want f of x, right? The original polynomial. We divided by 2, so now we have to multiply by 2. You want to keep everything in balance, as they say. Divide by 2. Okay, so now we multiply by 2. Now I'm just reminding you that g of x is f of x over 2 here. So now we're going to multiply by 2. And I didn't show the calculation, but I guess I can show it here, actually. Let me do that. You have 2 times this. Okay, so the 2's here are going to cancel, but I also have 2, multiplying by 2 on the right side here. And I am distributing. Basically, I get 2 times the first product plus 2 times the second term, which is the remainder. And from here to here, well, the 2 I'm distributing, get 2x minus 1. 2 times 17 over 8. 2 over 8 is 1 over 4. Then we have the 17. So when the dust settles, get this. So we have our f of x. Okay, that's good. All right. Are there any questions about this one? Now, if I went too fast, say so. I can, do it again if I have to. I'm more than willing. All right, well, let's do the next one then. So this was the third one. So we have this is our f of x, right? This was given. We have x plus 2. But with synthetic division, you always have to do x minus. No big deal. We can write this as x minus negative 2. X minus negative 2. So the negative 2 goes here. The coefficients go here. You can see that the polynomial here, f dividend, we wrote it in, it's already in standard form. And every power of x is accounted for. That is, there's no missing powers of x. So 5 minus 1, 2, 7. Now we do more work. 5 comes down. You have minus 2 times 5. That's minus 10. Minus 1 plus minus 10, minus 11. Minus 2. Right, so again, let me say it again. Minus 2 times 5, minus 10. Minus 1 plus minus 10, that's minus 11. Minus 2 times minus 11, that's 22, right? The negatives are gone. Sap and sun rule. Signs alike, the answer is positive. Signs unlike, and the answer is negative. 2 plus 22 is 24. Minus 2 times 24, that's minus 48. 7 plus minus 48, right? That's minus 41. We stop. There's nothing left. No columns. Okay. Our quotient is 1 degree less, so it's degree 2. These are the coefficients. So we get 5x squared minus 11x plus 24. The last number here is the remainder. We get that. So we have our f, right? That's here, is x plus 2. I mean, for this, I wrote it as x minus negative 2. We can put it as x plus 2 here, times the quotient, plus the remainder. Negative 41, I just wrote it as minus 41. So that's what we get here. All right. Okay. Now the instructions I gave here. Wait, sorry. Are there any questions on this one? I forgot to ask that. Okay. So for the next set here, the instructions I did not really write that well. I don't know what I was thinking, but basically I want you. Well, let me go through the first one, and from there you'll see what I want you to do. I mean, normally on a test or something, I'll give you better directions than this. For number one, basically what I'm doing is I'm giving you a root of the polynomial, which means f of that is going to be negative, f of negative 3 would be 0. So for the first one, we have negative 3 is a root of this. And what I want you to do is to factor f of x completely, is what I'm getting you to do. Here, though, we're using synthetic division. So what I did, this part you don't really have to do unless I ask you, but f of negative 3, I just double check is a root, as you can see. So I plugged it in, we get 0. And also, because f of minus 3 is 0, that also tells us x plus 3 or x minus negative 3, x minus negative 3, right? That's a factor of f. How do you get the rest? Well, what we're going to do is synthetic division. So we're going to do synthetic division. Okay, let's do that. We have x plus 3. Well, that's x minus negative 3, right? So the minus 3 we put here. The coefficients next, 2. So let me say this. You can see that there's no missing powers of x between the leading term and the last term. Like there's no constant term in f, but that's okay. We have 2, 16, 30. The 2 we bring down. We have minus 3 times 2. That's minus 6, right? So again, the 2 came down. Minus 3 times 2, that's minus 6. 16 plus minus 6, that's 10. Minus 3 times 10, minus 30. Okay, so again, 16 plus minus 6, that's 10. Minus 3 times 10, minus 30. 30 plus minus 30, 0. We kind of expected 0 to get as a remainder. If you think about the remainder theorem, which is really what I used here, well, not explicitly, I guess, f of minus 3 is the remainder if you divide by x plus 3 or x minus negative 3. So since this was 0, that's how we knew the remainder had to be 0. It's just the remainder theorem is what I'm using. That's all. So in other words, so what we end up with is the quotient's degree 2, is f is degree 3. We have 2x squared plus 10x. A remainder again is 0. So we have this, f of x is x plus 3 times the quotient plus the remainder. Remainder 0, so we don't write it. Now we can factor this. So essentially we're doing synthetic division first, then we're factoring the quotient. Although you probably could factor this directly if you were to get x out. But I'm demonstrating synthetic division here. So from here, right, if we factor this, well, I didn't write it out, but hopefully you can see that 2 is a factor of 10. The smallest power of x is x to the first. So the GCF is 2x. We factor that out. As you can see, we divide. To get what's remaining with dividing, so we get 2x times 2x squared over 2x plus 10x over 2x, right? When you factor, you put whatever you're pulling out, you put it in front. We have 2x times x plus 5. So altogether, this quotient we can write as 2x times x plus 5. Now I put the 2x in front here. I mean, if you left it in the middle, that's fine. That's what happens here. Okay, so number 2, I want everyone to proceed that way. You don't have to actually show that 5 over 2, if you do f of 5 over 2, you get 0. I mean, I did show that, but I'll do that with you. Okay. Let me just ask this first, though.